aorta into the left ventricle. This one messes up a lot. I've known lots of people that have had problems there. You think it's a big problem? You want blood to backflow where it's going to go to your body, back into your left ventricle? No. Big problem. You might not notice this one. This one you're going to start, your heart's going to start enlarging. The vessel walls are going to get bigger. And it's getting pretty routine to sew a new one of those in there. They got metal ones now. They got titanium ones. They got ones from cow skin. They got all kind of cool. I'd rather pass and not do it, but people I know that had it are fine. They help. We'll talk more about that later. Aortic semilunar valve. Now the problem in your book, a lot of times you get lazy and you start saying pulmonary valve. That's the one they're talking about. They say aortic valve. That's the one they're talking about. I like to put the word semilunar in there because I don't get confused. You start telling me aortic valve, I start thinking maybe, oh, that might be that one. So I like to use the whole name. But in your book, and doctors, they don't. I've never heard a doctor at the hospital say pulmonary semilunar valve. They say pulmonary valve. And they're talking about that. Okay, that's the only 4 valves you've got. And every mammal has those same 4. If you're a reptile, you don't have those. But that's for general biology. Okay, done with that. Let's go back to these valves down here and talk about these guys. Now this is where you start naming your kids. I tell you, people, name your animals and your kids. Think about this name to come to dinner. Hey, Corday. No, it's good. Corday Tendone. Corday Tendone Robertson. I didn't name my child. I did name my daughter, though, after a big football player, black guy for the San Diego Chargers, and she was mad. Kellen Winslow, you know? One more time. Corday tendone are these heartstrings, cords. They attach to the valves. And if you yank on them and you pull on them, it pulls them open. And if you relax them, what do you think the valve does? It flaps up into where it's supposed to go. So it's just, if you cut those, you're done. Now, when you go to lab this week, if you haven't done this already, feel those things, man. They are like a piece of steel. You have to take your scalpel and whack on that sucker to cut it. You can yank on them, they don't pull. They are tough suckers, and these cords attach to the valves, and they pull the valve open, or they relax and let the valve go where it wants to go with pressure. Okay, and you can imagine this when we start talking about the heartbeat. Cordae tendonae. Do the semilunar valves have those? No. So you're only going to find those on the bicuspid and tricuspid valves between the atrium and ventricle. All right, keep going down. I'm just going crazy. The chordae tendonae are all attached to special muscles called papillary. And when we start talking about physiology, you're going to learn that the papillary muscles and the ventricles get the stimulus first. When your heart has to beat and your brain sends a signal, it starts in the atrium, but when it gets down here, it comes to the septum, and it goes up into the papillary muscles first. So it yanks on the strings. When this muscle contracts, it pulls the strings. It allows the fill up with blood. So what are papillary muscles? They're muscles attached to the chordae tendonae that allow the valves to stay open. When they relax, they allow the valve to close, so they have jobs both ways, right? If you contract them and you pull on it, valve comes open. If you relax it, then the pressure will push that valve back and close the door. So they have all the control on what those valves do. The chordae tendonae. You don't have to be able to spell it. Lab you do, and here it's going to be multiple choice.
The chordae tendonae controls the papillary muscle?
No, the papillary muscle controls the chordae tendonae. It pulls, it's the muscle that is attached. It's just cardiac muscle. It's the same muscle as here, except it has a cord attached to it. It would look just the same as the mic. If I took a microscope slide and cut right here or cut here, they would look the same. Still contracts with the heart the same way. Okay? Just randomly going around in circles. Oh, look at this word. Trabeculae carni. What the heck is trabeculae carni by looking at that picture? We'll make your own definitions. It's in the endocardium. But it goes into it's also myocardium. It's both. The trabeculae carni have a layer of endocardium on them, but if you cut into that little ridge, it's still myocardium. I would like my heart to be pretty. And if I cut it open, I'd like to see my ventricle be smooth. It looked real cool, like a smooth little container, right? It doesn't look like that. It's like an old nasty, rough, pitted thing. You been in the lab and seen your muscle yet? It was nasty looking in there, right? That was normal. What does that do to make it all pits and holes and everything?
More space.
More surface area. Two things. I can put more blood in there. Instead of a smooth box, I can put more blood in all the gaps, plus it gives me more muscle cells to contract harder. So the trabeculae carni is a good thing. More surface area. Your brain, what's it look like? Is it smooth like a, maybe yours, not mine. What's your brain look like?
Grooves and
Grooves and depressions and gyruses. More surface area. Intestines. More surface area, digest more food. Heart. More surface area. Put more blood in there. I guarantee if I take a cup and I make it smooth, it's going to hold a certain amount. If I put depressions all in the glass and holes, it'll hold more. Also, this can contain more muscle cells because there's more space. That means I got more contracting power. It's ugly, but it's right. So the trabeculae carni is the, I've got definitions written down in the next few slides, but it's the ridges and the ventricles that add surface area. That sounded good. I just made that up. But the ridges and the ventricles that add surface area. And everybody has it. Nobody has a smooth heart on the inside. If your sheep had that you cut open, it wouldn't have been alive. It's not papillary muscle though. It's the same under the microscope. It would look the same, but since there's no cords attached, it's just contracted muscle. That's what makes the ventricle contract. You got them in the left, and you got them in the right. Okay? Done that, done that, done that. Got this thing. Got to know that. What is the, by definition, what does the interventricular septum do? It separates the left and the right. If I didn't have that, I'd have one big chamber down here like a bird. We're not birds. So we have 4 chambers. So the interventricular septum separates right ventricle from left. What's it made of? Myocardium. That'll learn the words now. Everybody's got one. If you don't, you're not sitting here. Or you're a bird, or a lizard, or an alligator. There's an alligator in my finger at Fort Isabel. We're going to get it. You saw it. The girl, I said, oh, the girl next to me, my condo came over. Hey, you're lying. You didn't see it. You saw a damn bird down there or something, you crazy woman. And she brought me a video of that big sucker swimming right by with my boat. And when we get it, we'll put a chicken out there on a hook, and we'll bring y'all some alligator tail. Okay.
You separate the vent.
Why are we talking about alligator?
You separate the vents.
Separates, it makes a left and right ventricle. No, you got one of them too, but it's okay. Let's go on.